Prove that minus 1 plus iota raised to 7 is equal to minus 8 times 1 plus iota. So to prove this equality, first of all we are going to write the given complex number z is equal to minus 1 plus iota. We compare with x plus iy. So if you compare here, you will get x is equal to minus 1 and y is equal to 1. Next, we are going to convert the complex number z is equal to minus 1 plus iota into a polar form. So what is a polar form? The polar form is z is equal to r time cos theta plus I times sin theta, and here r is equal to under root of x square plus y square, and theta is equal to theta depends on the location of the complex number. So here we are going to discuss the theta later on. So here what is given here, x is minus 1 and y is 1. So what is r here? R is equal to under root of 1 square plus minus 1 square, so this is equal to under root of 2. Now the location of the given complex number is on the second quadrant, that is minus 1 1 1 1. So here theta is equal to pi minus tan inverse of mod of y by x. So we can use this formula to find the theta. So here theta is equal to pi minus tan inverse of, what is the value of y? Y is 1, y is minus 1, x is 1, sorry, x is minus 1 and y is 1. So we can use this is equal to mod of minus 1 divided by 1, which is nothing but pi minus tan inverse of 1, which is equal to pi minus tan inverse 1 is pi by 4, so this is equal to 3 pi by 4, and hence r is equal to under root of 2 and theta is equal to 3 pi by 4. Now the polar form of z is equal to minus 1 plus iota is equal to r. So r is equal to root 2 and cos 3 pi by 4 plus I times sin 3 pi by 4. So we express the given complex number into polar form. Now use the De Moivre's theorem. Using the De Moivre's theorem, we can write, okay, minus 1 plus iota raised to 7 is equal to root 2 raised to 7 into cos 7 times 3 pi by 4 plus iota sin 7 times 3 pi by 4. So this is what De Moivre's theorem. What De Moivre's theorem says? The De Moivre's theorem says that if you write the given complex number in a polar form, then r times cos theta plus I times sin theta raised to n is equal to r raised to n cos n theta plus I times sin n theta. So this is what the De Moivre's theorem. So we use here De Moivre's theorem. So this is equal to, now root 2 raised to 7 is equal to root 2 raised to 6 into root 2, and this is equal to cos times 21 pi by 4 plus I times sin 21 pi by 4. Now I want to simplify this. So we know that root 2 raised to 6 means what? This is nothing but 2 raised to 6 by 2. 6 by 2. Since root 2 is 1 by 2, root 2 and we can write this 21 pi by 4 as cos 5 pi, say 5 pi plus 5 by 4 plus I times sine 5 pi plus pi by 4. Since this, if you simplify this again, you will get the 21 pi by 4. So what is 2 raised to 6 by 2? This is nothing but the 2 raised to 3 into root 2 inside the bracket. Now we can write this is equal to cos 2 pi plus pi by 4 plus I times sine 2 pi plus pi by 4. So we okay, not 2 pi, it is equal to 4 pi. Instead of 2 pi we write this 4 pi, and we know that the cos 2 pi plus theta or cos 4 pi plus theta is equal to cos 4 pi plus theta is equal to cos theta, and sine 4 pi plus theta is equal to sine theta. So by using this formula we can write now 2 raised to 3. First of all we have to simplify this. 2 raised to 3 is 8 root 2 inside the bracket. This is equal to cos pi plus pi by 4 plus I times sine pi plus pi by 4. Now again, what is cos pi plus theta? Now again, if you see, the pi plus pi by 4 is lie in third quadrant, and in third quadrant tan and cot are positive, only positive. So here, since we in our it involves the horizontal line, the cos remains same. Cos pi plus theta is cos theta. So here we can write this is equal to 8 root 2. Cos remains same since it is a horizontal line, pi 2 pi, so cos remains same. So this will be equal to minus cos pi by 4 plus minus I times sine pi by 4. Since we know that cos pi plus theta is equal to minus cos theta, and sine pi plus theta is equal to minus sine theta. So this will be equal, now cos pi by 4 is equal to, this is equal to 8 root 2 minus 1 by root 2 minus I times 1 by root 2. Now take 1 by root 2 outside, we get this will be equal to root 2 divided by root 2 minus 1 plus I, minus 1 minus I, minus 1 minus I. This root 2 will get cancelled here. This is equal to 8 times minus 1 plus minus 1 minus I, and this is what we want to show here. If you see, this is what our question show, that minus 1 plus I raised to 7 is equal to minus 8 times 1 plus I. So if you take the minus sign outside, this will be equal to 1 plus I. So here if you see, the first we write the complex number in the, we compare with x plus iota, then we find the value of x and y. By using this we convert this into a polar form. X is z is equal to r cos theta I times sin theta, where r is equal to under root of x square plus y square, so it is equal to root 2, and we find the theta which is equal to 3 pi by 4, and then we use the De Moivre's theorem to find minus 1 plus I raised to 7 which is equal to root 2 raised to 7, and we simplify, we use some trigonometric formulae to reduce the given equation, and finally we get it is equal to minus 8 1 plus I.